Good morning, students. Today we are going to discuss energy consideration of reaction. First of all, what is meant by activation energy? A reaction always proceeds by breaking of bonds in the reacting molecule. Therefore, whether a reaction is exothermic or endothermic, energy must be given from some source to break the bond. Molecules of reactants are in the state of rapid motion and possess kinetic energy. The reaction occurs when the reacting molecule approach in a proper alignment and collide. On such a collision, the kinetic energy possessed by the molecule is transformed into potential energy of the system. It is the important. Thus, to start a reaction, required energy is supplied by the collision of the reacting molecules, where rate could be enhanced if necessary by heating. The minimum amount of potential energy that must be provided by collision of reacting molecules for a reaction to occur is known as activation energy. It is denoted by EA. Suppose C is reacted with a molecule AB to give Ca plus B as a byproduct. Generally, a graph is plotted potential energy versus progress of activation energy. So this graph's nature comes like this. This point indicates transition state. This point indicates potential energy of reactant. This point indicates energy of product. So reaction can be two types, that is exothermic reaction and endothermic reaction. Just see the graph for exothermic reaction. Here we see that potential energy of the reactant is greater than potential energy of the product, and that's why delta H, that is enthalpy change value, is always negative in exothermic reaction. In endothermic reaction, we see that potential energy of the reactant is less as compared to potential energy of the product. That's why delta H, that is enthalpy change in endothermic reaction, is always positive. Now we are going to discuss transition state. Just see this reaction. In this reaction, these are three atoms, that is C, A and B. It is joined by dotted line. What it means? Transition state can be defined as extremely transitory specific arrangement of atom or a group through which a reaction system must pass on its way to give the products. Transition state has extremely short lifetime, and once it's passed, it decomposes to give products. It cannot be isolated. It is important. Transition state cannot be isolated, or the arrangement of the atom which are present in the transition state cannot be isolated. Now we are going to discuss reaction intermediates. An intermediate is a stable entity and can be isolated under appropriate condition. It is important. A reaction which proceeds through a intermediate has passed through two energy barrier, one for conversion of reactant to intermediate, here, which is denoted by EA. So from here to here, the transition state first. Here conversion of reactant into a transition state takes place, and just see the second term here, and the other for conversion of intermediate to the product, that is EA-1. So in this case, conversion of reactant into transition state take place. From here to here, after here, conversion of intermediate to product takes place. Now we are going to discuss different types of reaction intermediate. Various reaction intermediates that we come across in the study of organic reactions are carbocation, carbanion, carbene, free radical, nitrene. Now we are going to discuss formation, geometry, stability and reaction of reaction intermediates. The first reaction intermediate which we discuss is carbocation, a species which has a carbon atom bearing only 6 electrons having a positive charge is called as carbonium ion or carbocation. Now, how carbocation is formed? In tertiary alkyl halide, heterolytic fission of CX bond, an electron pair is retained by halogen atom and carbocation is formed. Basically, if we take a tertiary alkyl halide, so this bond is undergo heterolytic fission to give carbocation. In a second reaction, we see that ethylene is attacked by a proton to produce ethyl carbocation. Now we are going to see characteristics of carbocation. They are short-lived species. Carbocation have very strong tendency to complete the octet, and consecutively they are highly reactive species. Either they combine with nucleophiles such as OH-, Cn- ions, or may lose a proton to form alkene. The loss of proton takes place from adjacent atom. So just see here, this carbocation is very reactive and it is always in search of nucleophiles. So nucleophile can easily attack here to form a bond. So here OH- acts as a nucleophile to give ethyl alcohol. In this carbocation, loss of proton from adjacent carbon atom takes place and we got ethylene. Now we are going to discuss stability of carbocations. Methyl carbocation is less stable than primary carbocation. Primary carbocation is less stable than secondary carbocation. Secondary carbocation is less stable than tertiary carbocation. Tertiary carbocation is less stable than your allylic carbocation. It means that allylic carbocation is highly stable. The resonance stabilization of allylic carbocation enhances its stability. Why this carbocation is more stable than tertiary carbocation? Because in this case, one can easily shift this bond here, or this bond can easily be shifted in between these two and charge is shifted on this carbon. like this. Because of resonance, this carbocation is more stable than tertiary carbocation. Now we are going to discuss structure of carbocation. The carbon atom of carbocation is sp2 hybridized. It is important. The 3 sp2 orbital form 3 sigma bonds with substituents. The unhybridized p orbital, which is perpendicular to the plane of 3 carbon bonds, is remain empty. So just see here, this empty p orbital is perpendicular to your these 3 hybrid sp2 hybrid orbital. The angle between hybrid orbital is always of 120 degree. Now we are going to see reaction of carbocation. The carbocation are easily attacked by nucleophile. So here OH minus acts as a nucleophile. So it attacks on this carbon to form a bond to give alcohol molecule. Just see, in this tertiary carbocation, the lone pair of electron which are present on oxygen attack the carbon to form a bond. Because of that, oxygen got positive charge. To remove this charge, the electron which are present in between oxygen and hydrogen bond, it shifted on oxygen and H plus easily removed to give a product. Now elimination to form olefin. If there is no reagent or no nucleophile is present in the reaction, in this case the hydrogen atom which are adjacent to a carbon carrying positive charge donates their electron to form a bond between carbon-carbon, and H plus is easily removed. That's why it is elimination reaction, and we got olefinic molecule. Rearrange to form more stable carbocation. It is important. This is important stage. So just see here, it is a primary carbocation. This charge can easily shifted on this carbon by placing this hydrogen on this carbon. So in this case, the electron between this carbon and hydrogen is shifted on this carbon, or this hydrogen is shifted, in this case this hydrogen is shifted on this carbon and this carbon got positive charge. It is a primary carbocation. It is the secondary carbocation which is more stable. Add to form alkene to form big carbocation. In this case, tertiary carbocation is attacked by this alkene molecule, and we see that we got bigger carbocation molecule.